Now, this is the next one which I was talking about, this simultaneous transmission and reception, also known as full duplex. Right now, we do only half duplex. FTD is half duplex, TDD is half duplex. All right, he is thinking why FTD is half duplex. Okay, all right, TDD is full duplex, but you are using two roads for two directions, and so basically, what it is that you could get on both roads two-way traffic. That's what we want, really. I mean, if there's a name for it. So right now, on the down direction, we cannot do up. On the up direction, we cannot do down. Can we do both up and down on both directions? All right? And so the answer is yes. This is the latest stuff. This is not, basically the thing is, now once these guys discover it, then it will come to 11, it will come to everywhere else in the world, right? But this is 2016 stuff. Actually, this is 2010 stuff. But, so the idea is why they don't do it? Because there are several problems. There are many, many issues. First of all, your own signal will interfere with yourself. If I'm speaking and I'm trying to listen, very difficult, right? And everybody in this room, they started speaking and listening, then it is impossible, right? So the thing is, because my own signal is going into my brain and processing and everything else, and so the ears have lower priority. But since I know my signal, I can subtract it out, all right, and do, basically processing of the received signal also. But there are other problems, but anyway, so the thing is, because the transmitted signal is too strong, and second thing is there is a large gap between the transmitted and received frequencies. So here, if I'm transmitting, I will have to put my RF. I don't know where to put my RF because this is RF chain is occupied for that, and this is a different frequency, different filters, different things required, right? So that is another one, and in TDD, time is okay. Solid. Solution is self-interference cancellation. It can be done in the analog or digital domain and digital domain. Basically, is that you know what you're talking, subtract that out. So actually, when you use a full duplex speakerphone, that's exactly what you do. Is that when you speak, you don't listen to yourself. Basically, the speaker cancels it out. Yeah. The same thing as TDMA. Now, okay, so it is different concept than PDMA. PDMA was pattern division multiple access, where every user subtracts out other user signal, not their own. Right? So the nth user has to subtract out 1, 2, 3, 4 to get to itself. Right? And one doesn't have to subtract out anything, it is done. It gets the signal and it has the highest power, it's done. So PDMA is subtracting out other people's signal. Here, you have to subtract your own signal. Right? And then, the problem is also that if two UEs are talking, and we are talking in this direction full duplex, this is talking full duplex in this direction, there is interference of all kinds at the same frequency at the same time. So it's not trivial. And the reason we didn't do so far is because the cost is high. So if somebody comes up with a cheaper method of doing the thing, then it will happen. All right? People have started thinking about it. The paper is 2010. Since it has not been implemented so far, it means, it will happen someday, but people are just still trying to simplify the chips. Simplify the IC circuits. Okay? But you can see, things that we never thought before are now seen that people are thinking about. Dynamic TDD. Dynamic TDD has to do with that in TDD, you speak for some time, download, and then you upload for a short time. And the idea was that most people don't upload anyway, so we can do more download. Right? But the problem was when they started implementing TDD, they realized that you cannot do it. You really have to have a fixed time. if I decide that I want to do half-half, C has to do half-half, he has to do half-half, he has to, all the basis systems have to do same ratio. Okay, and the same time actually, not just ratio. When I'm doing down, everybody's, doing down. When I'm doing up, everybody's doing up. Because if I'm doing down and you are doing up, your car or your mobile user will not be able to be heard because my transmission is so high powered that the mobile users are being drowned. Right? So every transmission, when there are neighboring cells, they have to do the transmission and reception exactly at the same time. So what 3GPP has done is given 4 combinations possible, 7 combinations, 1, 2, 3, 0 to 6. And they decide that, okay, all right, in this area in St. Louis, they're going to use 0. All the basis stations will use 0, which means that they will do D, S, U, U, D, S, U, U. D is down, U is up, S is switching from D to U. You need time to switch. For any cell. Okay? So everybody decides that in this area we are going to use this pattern. There are 7 patterns allowed. Different patterns have different D's and U's, and so they give different ratios. But you cannot use 8 simply because it is very impossible to just convey myself to tell you that what I am using. Otherwise, I have to tell you the whole vector, and then you have to use the same vector. So we just decided that we are all going to use 3. Done. Okay. However, this is not dynamic. This is static. Static means this will remain there for the next year. Right? So we're not going to change it. So now the question is, why don't we be dynamic? We need to change with the time, change with the demand, change with whatever reason you need to change the ratio. So all this is basically, is that dynamic TDD is that now they have defined a new combination in which you have D, S, U, S, and S, D, F, S. So F is flexible. Okay, so I can put a D here or U there. If I put D and U, then I have to put a S somewhere, and so it is flexible. So now I have to really send a vector to you. If I want to change something, I have to change it, set a vector. Okay, and you can change every 10 milliseconds, which means every superframe. And then we will have to, because there will be interference, so we will have to have some enhanced interference mitigation and traffic adaptation. Basically what that means is that we will have to change the pattern, and then the mobile will be asked to change it. And traffic adaptation simply means that depending upon the upload and download, we will change the U's and D's. Okay? And this will be further. So this is already there in one of these releases, 13, 14. And this will be further enhanced for 5G. This flexible frame is there. Not in 4G, in 13 and 14, right? So we are way beyond 4G now, in at least 3GPP. F/D. Either could be switch or could be D. Because if it is D, then you can have 2 Ds right there. D, D. You don't have to switch. But this will become F. F becomes what, so that we have to make a switch here. What is F is? If F is D, then we don't have to switch. Right? If F is U, it is switch. There are 2 stages here. First stage is maybe release 11, 12, I forget which release, in which you have to select one of the 7. Then there is one release in which you just declare one of the 7. I mean, you can change so often, right? And then there is one release in which now this F is introduced where you can more than 7. You are not limited to 7. Okay? So this is a matter of releases as to when more flexibility is coming in. Yeah.
How often they change the pattern?
They can change every 10 milliseconds as said here. Yeah, so the question is, it takes too long. Too long is actually very short. Now, as you saw, the things are going into millisecond range. And so the message to go from one end of St. Louis to another end of St. Louis probably is few microseconds, speed of light. And so yes, so basically if 10 milliseconds is a super frame, right? So
all the neighbors should be aware that you are changing the pattern.
And they have to agree to it, right? I mean, if suppose I have too much traffic which is going downlink and you have too much traffic which is going uplink, we not agree. You say, no, hold on, I will get into trouble if I just change mine, right? So there has to be some agreement. I think this is dynamic TD probably not going to happen that often, but it is allowed every 10 milliseconds. So what will happen is when I want to change, I will tell everybody and they will say, yeah, all right, if we all agree, then we change.